polynomial functions. In this video, we will talk about some of polynomial functions like constant function, linear functions, and quadratic functions. Today, in this video, we will talk about constant functions and linear functions. And the first, constant functions. Okay? The constant functions mean what? The function f is a function from R to R, where fx equals p, and p belongs to R. It's called a constant number, okay? So the function of the constant function, fx equals p, okay? And p not equal to R. This is called constant function. Like what? Like fx equals 3. Fx equals 3 here, p equals 3. And it is written as y equals 3. Y equals 3, okay? Now, I mean fx equals 1, fx equals 3. And fx equals negative 1, fx also equals 3. Fx equals any number, fx equals also 3, okay? So, x equals negative 1, y equals 3, x equals 1, y equals 3, x equals 2, y, fx equals 3. Now, we need to represent this constant function graphically, okay? So, to represent the constant function graphically, it is represented by straight line parallel to x-axis, okay? The constant function represented by straight line parallel to x-axis and passing through the point 0 and p. Here, fx equals 3, so p equals 3. So this straight line passing through the point 0 and 3, okay? And we know something, okay? If p greater than 0, this is x-axis, okay? If p greater than 0, so the straight line above x-axis like this, okay? X-axis, if p greater than 0, the straight line above x-axis. But if p less than 0, the straight line through x-axis. Okay, through x-axis. But if p equals 0, the straight line coincident the x-axis. Okay, if p equals 0, the straight line coincident the x-axis. Okay. The second polynomial functions today is linear function. The linear function. Linear function, its definition is f is a function from R to R, so domain in R, where fx equals ax plus b. It's rule for linear function ax plus b, okay, where a and p belong to R, okay, and take care, a not equal to 0, okay, a not equal to 0. This function is called a linear function, or function of the first degree, okay? The function of the first degree. Because what? Because the index of x here equals 1, okay? So this function, ax plus b, is called linear function or function of the first degree, okay? Here, f is a function f is a function from R to R, where fx equals x minus 1. Another one, f is a function from R to R, and fx equals to x plus 1, okay? Here, f is a function from R to R, and fx equals 3x. Not something here, okay? Here, in each function here, the index of x equals 1. graphically, okay? For example, represent graphically the function f. F is a function from R to R, okay? The root function is fx equals 2x minus 3. Now, I need to represent this linear function graphically. So, we need to find two of ordered pairs. Two of ordered pairs belong to this function, okay? Like the first one, if 0 equals what? Here, when x equals 0, if 0 equals -3, only substitute by 0 in this function, okay? So when x equals 0, y equals -3. Also, if x equals 1, if 1 equals -1, because 2 times 1 equals -2 equal 2, minus 3 equals -1. So when x equals 1, y equals -1. Now, we can find the third order pair to check the 3 points on the same straight line or linear, okay? Only to check the 3 points on the same straight line. So the third order pair is when x equals 2, the f2 equals 1. Okay, because 2 times 2 equals 4, minus 3 equals 1. So when x equals 2, y equals 1. We can write this data or this order pairs in one table like this. x0, y -3. x1, y equals -1. x equals 2, y equals 1. Okay. Now, we can label the three order pairs on the square, on the perpendicular square net like this, okay? Here, okay, in the graph or in the square net, only label each order pair 0, -3, 0, -3, and 1, -1, 1 and -1, last one, 2 and 1, 2 and 1, okay? Then join the 3 points together to draw a straight line passing through the 3 points, okay? Like this, okay? So the straight line, this straight line represents the function 2x minus 3. Now, the point of the intersection with y-axis, okay? The point of the intersection, this is straight line with the x, with the y-axis here, 0 and -3. And this rule is 0 and p, 0 and p. Our function here, if x equals 2x minus 3, so p equals -3, p equals -3. So the point of the intersection with y-axis equals 0 and -3, and we can find it from the graph, 0 and -3, okay? The second one, the point of the intersection with x-axis, okay? I talk about x-axis, the value of y, 0. I talk about y-axis, the value of x is 0, okay? Y-axis, the value of x, 0. X-axis, the value of y, 0. The rule to find the point of the intersection with x-axis equals order pair -p over 2 and 0. I said p equals -3. So negative, positive. So the point of the intersection with x-axis equals the order pair 3 over 2 and 0. Okay? Last something, okay? If our functions 2x minus 3. Now, if p equals 0, the function becomes what? Becomes 2x.